Dear students, welcome to the module on the quantitative description of solutions. This module will provide you with an overview of physical quantities that are used to quantitatively describe the composition of solutions. A liquid solution is a homogeneous mixture of two or more substances. It comprises a solvent, which is the liquid substance that dissolves other components, and one or multiple solutes, which are the substances that get dissolved in the solvent. Typically, the solvent is the component present in the largest amount. The amount of every component in the mixture is characterized by its mass and amount of substance. Additionally, we will consider molar mass of each component that connects its mass and amount of substance. In the following formulas, the solvent will be denoted as component 1. The mass of the solvent in the solution is denoted as M1, the amount of substance is N1. All solutes will be denoted as components 2, 3, and so on. The mass of the solute I is Mi, the amount of substance is Ni. Additionally, the whole solution is characterized by its volume V. Unlike mass and amount of substance, the volume of a solution is not additive. If we mix few substances to create a liquid solution, the volume of the solution will not be a sum of the volumes of original substances. The composition of a solution can be described using mass and mole fractions, which are defined as follows. For any component in a solution, including the solvent, the mass fraction of the component, denoted by W, is the ratio of the mass of the component to the total mass of the solution. Expressed as a formula, the mass fraction is M over M total. The mole fraction, denoted by X, is the ratio of the amount of substance of the component to the total amount of substance in the solution. By definition, the sum of the mass or mole fractions for all components in a solution is always 1. It's worth noting that mass or mole fractions can be used to describe the composition of any mixture of substances, not only liquid solutions. Another way to quantitatively describe solutions is to use various concentration units. Mass concentration, denoted by the small Greek letter ρ, is the mass of the component divided by the total volume of the solution. Molar concentration, or molarity, denoted by C, is the amount of substance of the component divided by the total volume of the solution. Both types of concentration are typically used to express the content of solutes in the solution. It is also possible to calculate either concentration for the solvent, although it is rather unusual. Molality, denoted by B, is the amount of substance of the component divided by the mass of the solvent. This definition also implies that molality of the solvent is meaningless as a description of the solution. Note that unlike fractions presented on the previous slide, these concentration units possess corresponding dimensions, and their values are measured using corresponding units.